Hello everybody, my name is Dave Neary. I am the Eclipse Che Community and Ecosystem Manager.
And my name is Gorkem Ercan, and I'm a Senior Principal Software Engineer working for Red Hat. My responsibilities include Che as well as other development tools.
So today we're going to give you a brief introduction to Eclipse Che. Just as a show of hands, who here is familiar with Che already? Who here is not familiar with Che? So there's about 20–30% of the room is not familiar with Che, so we'll go through this quite quickly. It'll be pretty high level because the meat and two veg of this presentation is going to be given by Gorkem around the architecture that we have for Eclipse Che 7, in particular all of the ways in which you can extend Eclipse Che 7, and then we'll talk a little bit about what's coming next after Che 7 and how to get involved in the community. So as a brief introduction, development has changed, right? Traditionally, we develop on a desktop for a desktop or a bare metal server. Increasingly, companies are either planning to move to the cloud or planning to develop on containers or have already moved to the cloud and are waiting for the development tools to catch up. And yet, some of the same challenges continue to exist and in fact have gotten worse as we move to this cloud-based environment. As you move to a decomposed application, as you move to microservices, config and setup becomes harder, observability becomes harder, management becomes harder. Integration with dev tools is a problem for, this is a survey that was done a couple of years ago. 41% of enterprises lack development tools that integrate with their deployment environment. And so we have the 10 principles, something that has been kind of a mantra for this development tools team. To summarize, development will be done in containers. Setup and management time should be reduced to the minimum possible. We want to allow developers to integrate more easily with a DevOps toolchain, with operations and deployment. And we want to improve and standardize that end-to-end process so that we have tight inner loop and also good interconnection with the outer loop, that bringing software from development to test to pre-prod to production. And that's where Eclipse Che comes in. So Eclipse Che makes developing containerized applications easy in a number of ways. First, it is a container application itself. It runs on a container orchestration platform. We manage developer workspaces, which are themselves multi-container applications. We enable you to onboard new developers with a single click by defining how a workspace is put together. And when you either use a Che file or when you click on a factory link, we create a workspace which is an exact copy of the workspace that was created from. So it enables instant onboarding of new developers. I remember my first job, we had 2 days of training in the SCM tool and we had 2 weeks to get a build working. Those days are gone. Like the days of needing clear case training to figure out how to use the software are gone.
I recently had a talk with a person from a bank, and I was telling him that, oh yeah, you can take like a week to onboard someone. And he said, no, for us, it's literally a month before someone is able to start doing something.
Right. So in the cloud and container world, like if you start working for Netflix, they expect you to commit something to production on the first day you're working for them. So a tool like Che, which enables you to get the source code provisioned and get a development environment provision that mirrors a production environment instantaneously, that's huge. We remove inconsistencies by defining what goes into a developer workspace as being the same as what will go into the production workspace. You don't have this, oh, I'm using version 1.12 of that library, it works for me, but in production we have 1.9 and there's an API incompatibility, right? That's gone. And it protects the source code. We don't have multiple copies of source code, some of which is committed, some of which is not committed, going around on people's laptops. Source code is moved to Git repositories and developer workspaces that you're managing on your container orchestration platform. So you don't get any benefit from developers spending time to set up their environment. That time should go to 0. And we have this vision that you should be able to develop anywhere, on any hardware. You shouldn't need 32 gigs of RAM on your developer workstation to be able to do your work. You should be able to develop. Now that everything is running in the cloud, why not use that, that advantage, that parallelism, the resources that are available in the cloud, and just have your developer workspace be a terminal, essentially, to the cloud environment. So this opens the door for something which is, I think, as an open source developer, fantastic. It gives us the opportunity, for example, to have a link on my web page, try out the software here, make a change, commit a patch, and you don't have to have all of that bootstrap time. It enables anyone, anytime, to contribute to any project. And the way we do that is that we work with developer workspaces. So we start with containers. And this is in a Che 7 world. We start with a container which is what will be running in production, a base image that you will be running in production. To that, we add sidecar containers, which will contain language servers, developer tools, debuggers, root access terminal. And on top of that, we import the source code. So you now have your tools running in sidecars, your developer runtime with your source code provisioned in another container. And that enables you, because you have access to that developer workspace through SSH, that enables you to use our IDE, the web-based editor, which in Che 7 will be based on Thea. Or you can use any desktop IDE by exporting that over SSH to a local file system. Obviously, we think that the best way to use this tool is with the web IDE, but other options exist. And in fact, with Che 7, you have the possibility to swap out the IDE that we provide and use an alternative web IDE instead. And Gorkem will talk about that later. And then, because we have this idea of creating factories, creating a link that represents a workspace, or creating a Che file that defines a workspace, you can commit that Che file to your source control. It's versioned, it's with the source control, it's embedded in the source control. So that means that if you come back to a project 18 months after it was delivered by the last developer who's left the company and isn't with you anymore, you have the definition of exactly what versions of source code went into that production environment, and you can reproduce that development environment by having the Che file version with it. Or you can just have a link that gives you a workspace directly on your Che installation. And finally, we have collaboration options, right? So that the natural distributed development model is to collaborate via a shared Git repository. We also provide the means to share active workspaces. So you can allow multiple people in a team to connect to the same workspace and work together. And we're going to be developing increasingly collaborative work with collaborative editing and things like that in future versions. So we're turning developer workspaces from pets that you have to care for to the classic cloud metaphor, to cattle, replaceable, easily replaceable, redundant, and easier to manage. And some of the members of the Che community, well, we're a user of Che ourselves. When we demo our software, when we're running workshops with our software to customers, we use Eclipse Che to get people up and running quickly and allowed. SAP uses Che as the basis for SAP Cloud IDE. Software AG is developing software tools based on Eclipse Che. And then the second line is people who are using Eclipse Che embedded in a product offering that they have. CA is using Eclipse Che to offer a modern development environment to COBOL developers on mainframe. It's a pretty interesting use case. Bosch is integrating Eclipse Che, among other things, into the Eclipse Cuxa platform for automotive applications. And Cloud2Go has been selling Eclipse Che to Chinese banks, production, manufacturing companies, and even telecommunications companies. And then Progress, this is a relatively recent user of Che, is creating their next generation of their 4GL IDE, their IDE for developing database applications, building it on Che to give their developers a path to containerized applications. And Selexica have used in the past Eclipse Che as a vehicle to demonstrate their developer tools. So, swapping over, most of the rest of the presentation will be about, will be about Eclipse Che 7. So I'll hand you over to Gorkem, who is our architect and expert.
So Che 7 is our next major release that we are working on. We are at the, what I'll call a developer preview stage right now. So you can start playing with it. You can start doing extensions on it. We have, and we are pretty much stabilized on the extension mechanisms and all that, and the architecture. What we are working on is polishing up those flows that goes to that architecture. So just take that. So this is how did the Che 6 do the things. If you can look at it, then we had a code editor, UI widgets, and plugins to that IDE working on the browser, which talked with first to server to get the IDE, and then talked with the workspace engine, which we called the workspace agent, and a bunch of plugins that were running on that workspace engine. The problem with this one was everything was running on a single container here. The workspace over here is a single container that required us to create special containers for running your tools. We called them stacks, and the idea with the stacks were they were as close as it could get to your production environment. And the problem with that was it wasn't your production environment. It was a imitation of that. So on Che 7, we identified that this architecture is not going to be enough for us to continue providing the level of service that we want to provide to cloud applications. So we came up with five goals, which were written in this GitHub issue, finally. And then and we started implementing an architecture around these 5 goals back in February. And you can read them for yourself, but the main idea is we want to abstract the runtimes better with from the tools. We want to support multi-container applications better than we did with Che 6, and extensibility is the utmost important. And then we talked about the extendability of the web IDE. So our old IDE was a GWT-based IDE. So one thing that we looked at was, okay, GWT-based IDE is good, but the very natural way of extending that is at the build time, which is not always ideal. Therefore, we decided to look at the alternates. And one of the things that we did was, what do we want to build? What does our ideal world look like? And while looking at that ideal world, we came up with a list of stacks that we want to use, how we would build an IDE. And at the same time, Ericsson and Typefox were starting a project called Thea, and they showed us what they have, and we looked at it, and we looked at the stack and said, okay, this is what we wanted to do as well. Well, there is no sense in doing this ourselves. Let's join up with Thea project so that we can take it further. So we joined to the Thea project around the same time, and we were one of the initiators of the Thea project's move to Eclipse Foundation. So this is how the new architecture looks like. There's still a browser. It is running Thea IDE, and there are plugins to it. I will talk more about how that works. There's a Monaco editor and a bunch of UI widgets that are done in as part of the TIA framework. And then we still have the Che server, and Che server provides all these services. It provides a scheduler, it provides scalability, authentication, authorization. The factories are still part of Che server. Workspace composition is a big part of it. So you can click a link and then it gives you a workspace. That's the logic that is built into Che server. And once Che server determines that what you want to build, what you want to run as your part of your workspace, it creates a Che workspace. A Che workspace, as you can see, this is all running on OpenShift and Kubernetes. A Che workspace is essentially a bunch of Kubernetes resources with the images that you may want, with the images that the plugin editors want. So inside the Che workspace, we have the backend for the IDE, and then the backend of the IDE talks with a bunch of language servers, debug adapters, and tooling services. And I have specifically tried to put these as containers because they are containers. Your language servers, for instance, runs in a container that the language server provider has defined. So what does that mean? The advantage of that is, let's say that you are providing language server for Java, and you can provide the perfect Java VM with the perfect Maven configuration, with the perfect additional tools that you want to provide as part of this container, so that it is really one-click creation of the workspace. Think of the case for C++. You provide the correct compiler, the correct linker, the correct version of those, and so on and so forth. So it is always there, and it always works, because every dependency to your Java language server or any other language server is part of the container. You don't need to instruct your users to install additional pieces. And then the rest of the workspace is your application runtime. So if you have a Node.js application, that's one container. If your Node.js application is talking to a MongoDB, that's another container. We instantiate that for you, and you do your development, and during your development, you use your application runtime container and your MongoDB. You keep updating to your Node.js container, and your MongoDB is there. You can do your inner loop really fast. We have the debuggers there. If you want to put it into debugger, you can put it into debugger. And you can do even more interesting things. You can actually define that, oh, I want this application runtime to come from production. You can say that. And then you just use it from production. You don't need to always instantiate the whole picture as part of your workspace. You can cut and paste the workspace definition according to your needs from production. You can take a look at your production, and that's how it will work. You can take a look at your production and say that, oh, I want container A, B, and C as part of my workspace, but container D can be where it is. I'll just use that from production or test or development, depending on your setup. Another thing that we did with this release is the IDE itself, TIA itself, is our default IDE. So we had to come up with the term default IDE, because in Che, an IDE is an extension as well. So if you go to Che website as a demo, you can switch to Jupyter IDE on the same workspace. You just need to go to your workspace definition. There are the list of plugins. Remove TIA, add Jupyter, and it's the same workspace running with Jupyter IDE. If you're aware of it, there's a project called Eclipse Dirigible. They have they took something like 15 minutes to integrate their IDE into Che workspaces. So we will soon be shipping dirigible as part of Che as well. So you will be able to switch from Thea, go to dirigible, do some modeling, generate some code, and then go back to switch to Thea and then continue with your coding. All in the same workspace. So how does the Che server looks like? As I said, the Che server provides a bunch of APIs where your tools can talk with the Che server to create workspaces. This allows you to integrate Che into your workflows. So this is very important for us because let's say that as part of your build mechanism, you have an analysis tool which analyzes that, there's a security issue in this dependency. And then the analysis, the build basically just generates a report with a link to a workspace. And the way to create that workspace is through the APIs. It can just go to the APIs and say, create me a workspace, make it ready, and give me the link to that workspace. And Che will do that. It will create the workspace. It will not start it. It's just a definition on the database at this point. And then the moment that the user clicks on it, it will become a real workspace. So we have a big list of APIs that you can pretty much do anything that Che is capable of doing through APIs. And through those APIs, you can integrate Che into your flows. The other thing that it provides is authentication and authorization. We use, by default, Keycloak for identity management, identity and access management. However, you can swap Keycloak out and use your own as well. We actually do that in our products as well. It is standard space, but it is not very well documented right now. So we'll get there. And the data store, by default, we use Postgre. Lately, we introduced MySQL as well. We will be working on introducing more data stores, but it's more or less JPA-based data store. So it's just a matter of us creating those bindings. So we talked about changing the IDE, and we talked about the general architecture of Che 7. I'm going to just hook 2 talks that will happen today and tomorrow. One is concentrating on changing your IDE and how it is done. It gives you a good insight into how the Che extensibility works in detail. Alex is here. Say hi, Alex. He's one of the speakers on the talk. And later today, Florian and Yevhen is going to be talking about the Thea IDE and how we use that on Che. So how do you extend Che? There are 6 nowadays ways to extend Che. You can extend Che with sidecars to the workspace. And those sidecars will be included as part of the workspace, and then your IDE can talk to it. You can put a front-end plugin to Thea that will be running in the context of the browser in a web worker. You can put a backend extension to Thea, which will run in the context of the Node.js backend as a separate process, so it won't be part of the main thread. And then, of course, you can bring your own editor if you don't like any of ours. You can have a language server protocol implementation, or a debug adapter protocol implementation and hook that into TIA. And you can actually do extensions to LSPs or plugins. So we have a way of extending the extensions as well, because we needed to do that. That's the sort of thing you need. So here's how it works. On the browser side, you mentioned there are two ways of doing extensions. The first way is what we call front-end extensions. So the plugins actually work on a web worker, and this is all happening in the browser, and they talk with the plugin API to the plugins manager. And through these APIs, you can do several things. You can add menus, add commands, open files, close files, your usual API set. And the API set is an equivalent of Visual Studio Code API set. So if you have already a Visual Studio Code extension, or if you're familiar with that, that's basically you can reuse your code. If not, just repackage your extension. But the other way is what we call a backend extension. The backend extension works with the same plugin API, talks with the TIA backend, runs in a Node.js worker. This is a very similar infrastructure compared to Visual Studio Code. And because both APIs are equivalent both in backend and front end, you can actually have a choice between switching from backend to front end to backend. So think of the case when you may ask why we have two cases of it. Think of the case where your plugin is talking to your backend service. So if you have a backend plugin, that means that browser will talk to TIA backend. TIA backend will inform your plugin, and your plugin, which is running on Kubernetes, needs to talk to your backend service. If your backend service is part of the cloud service that is running the workspace, that's not a problem. But if your backend service is somewhere else hosted, then it means that it has to go through all this. Otherwise, if it's a front-end plugin, it could go directly from here and talk to your build service and give back the result. So that's why we have the two distinction between backend and front-end. And we take this, so this is very similar to what we have on TIA, but this is what we implemented inside TIA. What Che brings into this model is the container. So now you can have a container on the backend plugin that you can have a backend plugin that talks to services in a container and runs basically this process, or most of this process, in a container. This way, if you have a service that requires a toolchain to be installed, you can deliver that as a Docker image. And it's run and managed as part of the workspace. So how does the plugin instantiation work on Che? So when Che server receives a request to create a workspace, the first thing that it does is it looks into the list of plugins that it needs to instantiate. And to do that, it goes and talks to a service called plugin registry. Plugin registry is actually a container with a REST endpoint, which returns a big JSON file that lists the plugins, the information about the plugins that you want. And that information includes things like where do I get this plugin, what kind of an image I use for it, what is the name for it, and that sort of metadata. When that metadata is received, it is passed to an instance of a plugin broker. So a plugin broker is, again, a container that takes this metadata and initiates the plugin and modifies the workspace so that that plugin is part of it. So downloading the binaries for the plugin, adding the definition into the Kubernetes resource definition, and that sort of tasks are part of the plugin broker. So we do provide a list of plugin brokers, like IDE is a plugin broker, a Thea plugin has a plugin broker. But if you have a completely new kind of plugin that we haven't thought about, and you want to introduce that to Che, all you need to do is to come up with a new plugin broker and register that to the Che server, and we will create that plugin broker, and whatever that plugin broker does to download or to install or modify the workspace definition will be done. And these plugin brokers are sort of a short-lived containers. If you're familiar with the term, they are similar to init containers. So they get instantiated before the workspace is started, and then they get killed afterwards. So it's a way of instantiating init, well, I guess we can call them init workspace containers. And this piece is coming up. So what we will do is we're going to implement and run a Che marketplace, which will host plugins of any kind, including Thea plugins. And the plugin registry that you deploy, or the default plugin registry, will be using the Che marketplace, the global marketplace. But if in your organization you want to curate the list of extensions, then you will be able to replace this plugin registry. All you need to do is to implement the correct REST interface, and you will have your own list of plugins exposed to the Che server. So that's I think that's one of the things that we need to finish up before Che 7 is, we call Che 7 final. So what's next? I'm running out of time. What's next? Of course, this is a developer preview. We do have some performance issues we have already identified, and I'm pretty sure we have ones that we haven't identified. So we're going to be working on those before we release Che 7. Of course, we need to release the Che 7, get the Che 7 release ready. That means all the documentation, user information, extension information, and architecture diagrams like this needs to be ready for everyone to be able to consume. The extension marketplace, as I said, is something that we want to have before Che 7 is released. We are working on creating workspaces out of Kubernetes resources. It's the thing I talked about. You have a Helm chart. Che gives you an option to create resources that you select from a Helm chart through a bunch of selectors, what I call selectors. The next step is probably, this will start to happen after Che 7 release, is we are starting to trim down the resource needs for Che. One idea, for instance, is to pull the language servers so that we don't instantiate one language server per workspace, but rather use one instance of a language server for multiple workspaces. And then there are a few ideas that are even more crazy that we need to work on. More options for databases and identity management, they are coming. At least we need to get the correct documentation in place. And of course, there will be some integration coming in with tracing, like the Jaeger-based tracing, that's underway, and Prometheus integrations for metrics from servers and workspaces. And this is community stuff.
I do want to say that it's some of the features that were there are also going to be worked on by companies other than Red Hat, right? We have, for example, SAP are working on monitoring and observability. We also have community members working on accessibility, internationalization. So this is a community effort, not something.
Yeah, actually, the Kubernetes implementation is maintained and was originally written by SAP.
Also, the MySQL support was contributed from.
True, MySQL was SAP too. Yep.
Okay, so there are a number of ways that you can get involved, and I want to finish the presentation by giving you this call to action. The first is via the Eclipse Che marketplace. That is coming soon. It will provide a distribution channel for anybody who wants to distribute a plugin to the entire Eclipse Che user base. I encourage you to get engaged now in terms of having a plugin ready for that launch of that marketplace. We'll be getting documentation up this week. I believe it's written on how to develop a Che extension. We've had a 3-hour workshop here on Tuesday and a 1-hour workshop on Monday on that topic. So that's an excellent opportunity to engage with us and ensure that your tools and the things that you care about are available to Che users. We have a 2-weekly Eclipse Che community call, which is advertised on the Che developer mailing list. And we've recently added a new section to that, which I would invite you, if you are a Che user and are interested in sharing your story. We've recently started a section called the Community Spotlight. This is where we introduce a Che user who tells us why they chose Che, what they're doing with Che, the things they like about it, and especially important to me is the things they don't like about it, right? We want to create that high bandwidth conversation between our users and the developer base. So if you're interested in participating in that, come and see me after the call. We have a number of Che presentations here this week. After this one, Gorkem mentioned Eclipse Che Ide on steroids, which is, I've had a sneak peek of this, and this presentation knocks my socks off. So if you're interested in Che, I would recommend you go to that one. Harish Pillai from Red Hat will be mentioning Che during his keynote tomorrow morning. And we have 3 other presentations about Che, changing the IDE, benefits of Eclipse Che when developing microservices applications, because as I was saying, the goal here is not to just be a container IDE, it is to help developers develop microservice applications more easily, to deploy and take advantage of container management platforms more easily with your applications. And feedback from Aurélien Pupier on his experiences developing a language server protocol implementation for Apache Camel. And finally, I would like to invite you all to join the Eclipse Che community. We work on GitHub. We have a public mailing list. Our documentation is there, and I invite you all to try out Che. Please provide feedback if there's anything that goes wrong, either in a GitHub issue by contacting the mailing list or real time on mattermost.eclipse.org. And finally, we have a hosted instance of Che which you can try out that's running on OpenShift. It's at che.openshift.io, which will give you a flavor of what you can do with Che.
A bit of free resources, not too much.
Yeah.
Enough.
And that's it. How much time do we have for questions?
Nothing, but go
Nothing? So we'll abuse our privilege of being at the front of the room to take 2 questions, if there are questions, before we finish up. Yes?
When do you expect the release date of Che 7?
It's better be March.
Yes.
We should be GA by March.
we should have a beta before the end of the year.
Yeah. The GA should be March.
And thank you all for joining. If you have any questions that you'd like to ask myself or Gorkem, please feel free to come up to us after the presentation. Thank you very much. How are you doing? I'm Dave.
I'm the next speaker.
You're the next speaker. Oh, I thought you were going to ask a question. Excuse me.
Thank you. Hello, Andrea from CA. Oh, yes. I'm very happy to meet you. May I?
Just clear the space here for
I can't wait to
Yeah. Oh, you got the same thing? Yeah, everyone gets them. Pretty, got the market locked down, these guys. Yeah.